said, I'm Chris, talking about something that I've been struggling with possibly a lot over the last few months, which is containing our cardinality in Prometheus. So, a bit about me. I don't know why this is being weird. So, as Brian said, I'm an engineer at Splunk. We work on the internal observability platform for Splunk Cloud, providing something similar to the last presentation, so that was super neat to see. Also, the most recent, newest team member of Prometheus, which I'm very excited about. Just having a great time working with this community and giving back. We do all things observability, so tracing, metrics, all that stuff. It's all super exciting. And I love uphill skiing on the weekends. Get away from lift lines, pretty great. I recommend it. Get a good workout in. So first, questions. Who is concerned about cardinality in their system? That is a lot of people. Me too. So next off, who has seen this warning? I wish I could figure out what was up with that. On the Prometheus Docs. It's a good one. It provides some decent information. Don't store things like user IDs, email addresses, unbounded sets of data. Yeah, definitely avoid that. But what about if you're running a multi-tenant system? What about things like tenant ID? Is that okay? Is it not? There's a lot of fuzzy areas. And even if you do avoid all of this, I've been in situations where I have hundreds of thousands of individual series for one metric. So what can you do about that? That's what I'm hoping to address today. So, what is cardinality? So, for this talk, I really define it as the number of series held in Prometheus over a given time frame. Typically, that is at least how long sort of series are in memory for. That's at least 2-3 hours, something like that. Contributes a lot to the memory usage of Prometheus, and it's up to however long you commonly do queries for. Maybe you do queries that are a week long. You should kind of consider how many series will be in that week-long query. And then a few different sources of cardinality, targets, series on a target, and then also just how those change over time. So if you're running in Kubernetes, something like that, targets are constantly coming up and down. That adds a lot to cardinality that isn't necessarily reflected at any one point in time. And finally, cardinality is valuable. Like, yes, it's kind of a scary thing, but it's incredibly valuable, and things you can do with it are amazing. But yes, excessive cardinality is expensive. So how does cardinality hurt? First, more resource usage. Lots and lots of memory is a big one. CPU to some extent as well. Get really slow queries. Seconds might just time out, might stop working. Prometheus might reject them after a while. Hopefully it rejects them before you your Prometheus, which has been pretty good recently. So thank you for all the work there. Next one is just long startup times as Prometheus loads. So all that in-memory data, every time you restart Prometheus, it has to be reloaded from the write-ahead log. And that can take 15, 20 plus minutes. I've talked to a few people already at this conference in this very similar condition of they're just sitting there waiting. And then you get those big gaps on your graphs if you don't have some sort of deduplication strategy in front of it. And finally, in a lot of cardinality issues, even if you're running a high availability Prometheus, since there's usually you run two, scraping the same data, they're scraping the same data. That means similar memory usage. If you're going to run out of memory in one, you're probably going to lose the second one at the exact same time. And that really sucks. So, maybe. How much is too much? So this is just some things that I have found in our clusters. Your data is going to vary most likely. Try leaving full screen and see if that helps. No. Okay. So for a single metric, the idea is about 100,000 series. It's sort of a good rule of thumb. For some of our clusters, just doing a count query, pretty simple. 100,000 series, about 1.5 seconds. Kind of sucks to load a lot of dashboard, a lot of panels, but you can do it. It's okay. But by 200 series, like I'm seeing 5-second response times. If I go too much above that, it's just I start getting timeouts. Stuff doesn't work. So those are some rules of thumb for a single metric. And then as far as what can a Prometheus scale to, for a lot of the systems I run, I can get up to about 10 million series in memory. You can look at, so there's some good metrics to see that. And you can go above that depending on how well behaved your data is, but you start getting into, these are pretty big Prometheus instances. As I was saying, 15 plus minutes to start up. I'm exceeding 100 gigabytes of heap basically constantly. And if anything goes wrong, maybe not even in your code, but some third party has some weird cardinality issue, I found that it'll quickly just escalate and Prometheus is gone past sort of this point. There's not a whole lot of headroom anymore. And that's due to this sort of multiplicative nature of cardinality, which here's an example of what I mean by multiplicative nature. So regular, I want to know the latency. 100 instances, Prezi, they're running hundreds of microservices, seems reasonable. 10 buckets on your histogram, it's a normal amount of buckets. Times 10 endpoints, it's good to know how your different endpoints and routes are performing, cool. You're at 10,000 series, totally fine, Prometheus handles that great. If you add in 10 different response codes, it's useful to know if you're returning 200s, 404s, 401s, etc. You're at 100,000 series already, and that's sort of that limit. It's a little dangerous there. And then if you want to keep splitting up by something like, hey, it's gets and deletes and puts, how are they performing? You're already in the 400,000 series. If you try and add just 10 customer tenants, you're in 40 million. It gets bad pretty fast at that point. And I've not ever tried to push 40 million series in Prometheus. I don't know what would happen there. Probably not good things. And then finally, before I get into some tips of how you can actually prevent some of this, there's two types of data I commonly see in the Prometheus instances I run. One is operational data. So we've heard about SLOs a fair amount at this conference actually. You should have them, surface level objectives, they're great. And it's good to know when you're meeting those and alert if you're not. And the second thing is, I really like this operational data pointing to where the problem is in your system very quickly, and also providing evidence of the things that are working properly that you can rule out from this is where my issue is. And really operational data has to be very fast and very reliable. You can't just be missing alerts because they're delayed by 15 minutes and you get customer support cases before your alert goes off. That's not a fun situation. But then I also see many teams trying to put this more telemetry type data into Prometheus, and that is investigating things like how many users are using this endpoint or tenants or things like that. And this data is very powerful. It's really nice to be able to slice and dice all this data into, they're all using this customer is getting this type of performance, great. But usually that is someone asking about these ad hoc queries, or they can wait a few minutes, it's okay, it doesn't have to be as fast. And consider not putting that data in Prometheus is a big one. Prometheus is really good for operational data, but telemetry data is a lot of the time better sent to an event system. Clearly I work at Splunk, I can put it in Splunk, but whatever event system you want works great. So yeah, tips. How do you actually contain your cardinality? There we go. Tip 0. First off, I just like really being pragmatic. These are all suggestions. Something else makes sense in your systems. Everyone, you're the expert of your own systems there. And a few high cardinality series are okay. You have that up to 10 million. That gets you a pretty long way. So just think about what it is. Got Bard here. I will actually, do some work rather than just fighting cardinality all the time. I have to repeat that to myself occasionally. So, but yeah. First real tip. I really like thinking about how any label is used. This kind of gets back to that operational versus telemetry type data. If I'm getting woken up at 2 in the morning, well, first off, how many people are on call here? Also a fair amount of people. If I get woken up at 2 in the morning and I get a dashboard that has a bunch of labels that don't help me, I'm not super happy about that. So at that point, put it in an event system, put it somewhere else, keep it out of those core operational metrics. And is there a predictable number? Comes with that Prometheus warning. If you don't know how many numbers are going to be in this label, if it's something like raw error messages, which I have had show up in Prometheus before, don't do that. It hurts a lot. So yeah, good first way. Next up, something I find very powerful is just having your metrics really model your system. So common little architecture example, you have some sort of application, it's writing to some sort of queue, whatever, and you're sharding it by tenant ID, things like that. And say, you have one of those shards get backed up. Do you want to have those per tenant metrics that show, oh, these 5% of users are bad, are performing slowly? Or do you want to see, hey, this shard is backed up, maybe you need to reshard, or however your queuing system works, scale it up, whatever that is. I want to see the latter. I don't want to start by seeing, oh, okay, these customers are bad. What now? I can maybe hypothesize that a shard is backing up, but it could be maybe those customers are just sending weird data. It could be a whole lot of things. I'm going to have to go look somewhere. It's just much, much faster to have it model your system, have your metrics modeling your system. And then, third thing, using multiple metrics is very, very powerful. So we're back to our example of this histogram from earlier. 100 instances, 10 buckets, 10 response codes, 10 routes, 100,000 series. If you split that into 2 metrics instead, one metric that really focuses on the latency of your different routes, that's 10,000 series. That's 100 instances, 10 buckets, 10 routes. And then a second metric that is just the requests and the response codes, that still gives you all the same availability information you had. Another 10,000, 20,000 total series, 5x reduction in your cardinality. The only thing you lose here is you can no longer figure out your response time by status code. I have almost never tried to do that query in reality. Tom's looking at me with puppy dog eyes. Go use some access logs or something for that. It's very rare that you need that in an operational thing, and you save 5x. So pretty powerful there. It's not just HTTP that you can do this for. There's a variety that just you don't have to put every single way you can slice and dice a metric onto the same metric. Split them out a little. Works nicely. And then finally, if you find some value in your cardinality, you have those tenant metrics that maybe you do have a system that one tenant can perform very differently from all other tenants. We have some of that where like you can define custom pipelines and things inside of Splunk Cloud, and one tenant can have massively different performance, and we need to know that. At that point, try to limit how many high cardinality metrics you have. So maybe keep them just on your high-level API calls rather than on every single metric in that service. And then at some point, maybe even consider breaking it out into separate Prometheus instances. There's functional sharding, federation. If you're using long-term stores, maybe that becomes even easier. But you can just have one Prometheus still doing those local alert evaluations on this high cardinality data, and then only federate into the Prometheus that you're graphing from or things like that, the aggregations. Just have a couple layers here, at least even if something goes horribly wrong with that risky Prometheus, you still have your monitoring for the rest of your system. It's not all going to be down at the same time. You really get to avoid those awful situations. So yeah. Finally, some tools. How do you actually diagnose cardinality? Well, first off, Prometheus 2.14, actually, so that's release candidate out now. Come check these out. What you see on your right is actually displayed in the UI. There's a variety of different ways we can slice and dice sort of the top 10 or so cardinality metrics, and this has been very valuable for us. So this is an example is we provide the highest cardinality metric names. This example is actually from the prom bench, and you can see there is a single, that histogram has 8.7 million series. I tried querying that bucket. You can't do anything there. It does not work. But that can be very valuable. There's other ones of these, such as the cumulative size of all your label values, which, as I said earlier, I had a issue where error labels were being put into the full error messages were putting into my my Prometheus labels, and it exploded very badly. This was actually the only place I could find that was another one of these UIs where you will actually sum up all of that, because it didn't even show up in like my top 20 highest cardinality metrics. It was completely different. So yeah, check this out. If you want more added here, find it useful, let us know, or contribute to it. And then just a few useful queries. Things that really help tracking churn is scrape series added. Just taking a look at which jobs are adding the most series constantly. That's been very helpful for us. Another one, just scrape sample scraped, gives you a good idea of which jobs are just contributing the most to cardinality. And finally, that Prometheus DSBB symbol table size bytes. That's what really exploded for us in that error label thing incident. It was, I think it got to 60 gigabytes. And ideally this would be like a few hundred megs. So that's a decent one to keep an eye on. Yeah. So finally, thank you very much for your time. Hope you learned something about cardinality. If you want to hear some of the great disasters, Brian Borm and I will be talking in 2 weeks at KubeCon about when things go really, really wrong. So look forward to that, and questions.
Users. Testing. There we go. It's the delay box, I guess. So, what questions do we have for Chris?
Hi, thanks for the talk. In our company, we face a lot the issue that, for example, that in histograms there are buckets are adjusted. Sometimes people who start to work with Prometheus, they adjust the buckets in histograms incorrectly. So do you have any, I don't know, some technique or some query how to find out how to better adjust the histogram buckets?
So histogram buckets can be kind of tricky. I generally try to find about 10 or so that make sense for the system. And that might depend a lot on what you're trying to measure. Something like a DNS lookup needs to be much, much, much faster than maybe how long something is sitting in a queue for. So that ends up being kind of a personal choice of what is valuable, which makes it tricky, as you said, because people are going to be playing around with these, seeing what works. I would recommend, just generally for company practice, if you can define some sort of SLO, something saying we need 99% of things going through this system to be returned in 5 seconds, that should be the grouping for your histogram. And if you can start having those sorts of discussions, that really narrows down to where your histogram should lie, rather than, because if you have this SLO of 5 seconds, there's not necessarily as much of a need to also measure 3 minutes, because you're way out of SLO at that point, and it doesn't matter, you have an issue. So that has helped us some insight. Does that help? Cool.
Oh.
Okay, nice talk, thank you. Do you have any automated mechanism for detecting sudden increase in cardinality? Do you watch for that, and can you maybe recommend something for the community?
Yeah, so those couple of queries over here might depend a bit on what your system is. We have written some alerts around that. Those are pretty useful for us of just, okay, if symbol size is usually in our systems, I said it should be, in the hundreds of megabytes. In our systems, it's like 5 gigs. It's okay. We've got some problems still. But if we see that starting to, be 2x higher than where we think it should be, we've got some alerts around that sort of thing. And usually these are more warning levels. I don't want to be woken up for that, but I will go investigate and talk to teams. We are exploring some ideas around, is it actually possible to maybe provide limits on teams specifically, make it a bit more like, okay, this is what you get out of the box, and then if you go above this, you either get some sort of alert that we're going to start truncating soon. Things like that can sort of help. There's a Prometheus config where you can actually limit the size, the number of series you scrape from single targets as well. That can be helpful for just preventing fail scrapes instead of blowing up your Prometheus.
I'll note the initial issue that caused that metric to be added was only like 2-3 gigs. And there's also the TSDB Analyze tool, which is handy.
Yeah, so TSDB Analyze is similar to what I'm showing on the right here, but for older persisted blocks rather than just the in-memory data, but very handy.
Next question.
Well, not truly a question, but what we've done is that we have a script which analyze which queries Prometheus API and gets all the labels and the number of rows for each labels. So if something blows out, we notice.
Yeah.
Okay. I'm sure there was a question in there.
It's good advice for the community. I approve that.
Yeah, number of series touched. I think that's something we should expose in PromQL.
Yeah, there's just a head number of series.
No, I mean actual PromQL itself when it's executing a query. Number of series touched is,
Yeah.
I think it's in there somewhere. Any other questions?
Great.
3, 2, 1. Thank you, Chris.
Thank you very much.